data, central tendency is the tendency for the data to become centralized, like in the middle, go in the middle. Okay?
Okay.
But the other way of saying what a central tendency is to find the data that is in the middle, that that the value data in a data set you may have many different points of data, right? So if you look at this graph, this slide here, see there are many different data, right? Now which of this data point wants to be in the middle, right? So when you say data point, you also think about its value at the same time. So you say which of the data point and with what value does it always want to be in the middle. That's the central tendency kind of thing. Okay? So if you think about it, this is like distributed, right? All in different points. Now there's really you have a hard time of thinking where is the middle. So there's got to be a systematic way of saying, wait, if I really want to find the middle, let's arrange them
and
in a way.
it's not even a circle, like.
And it's not even a circle. You're exactly
that
right.
you can use a compass to like point here and point here.
Yeah, exactly. You're absolutely correct.
Like put it on a point and then see if it's that.
Right. So in the next slide, this is what I show. I show that somehow this could be the center.
We don't know that.
We don't know, right?
Yeah.
But the point also is that this point here, we don't even know really are these distances really equal, right? Because and we can't really measure them properly. So that
because this might be a longer distance than this might be.
Yeah, so you can't really say if that is the center or that is kind of representing everyone in the center. So what do you think is the best way? I would consider, okay, what do you think is the best way to say all these distances that you have from the center, I want to measure it exactly how it's distributed. What would be the best way to do it?
How to measure the center?
Yeah, like I want to say this value is the central value and then the rest is less or more than the center, right? What do you think? And then I tell you that you can redistribute this data point any way you like. What would you do?
What would I do? What would I do? I know. No, that won't work. Should I tell you my idea anyways?
Yeah.
My idea anyways was to like from here measure the distance and from here to measure the distance.
Why don't you show with the cursor?
Like from like here from the middle point of this area.
Show me with the cursor.
Yeah, from the middle point, like half, you make it half. Well, what I would do is like measure it here and then
Where?
see.
Don't move around when you say here. When you say here, say here. Put the cursor there.
Okay. Measure it from a point that's like longest. Like from here to here is the longest distance. So then that would be half.
Right.
That would be the place where it would be half.
Okay.
So I would measure that. Like, remember we had like the tablet for like that graphing calculator? I would actually measure it to like when it started to decrease, when it was getting up high.
Okay.
And that way, I can actually see it and then cut it. Like cut it. After cutting it, I will actually know from here the center already.
Okay.
Like I'll cut the center already.
Yeah. But what are you going to do with these data points? Here, all these data points. How are you going to measure that how far they're distributed from the center? What would you do?
What would I do for that situation?
So the question is, consider each dot representing time taken for something. Okay. Now the dots farther away from the center indicates more time, and the dots near the center indicates less time. Okay? So how would you do that? Like really know? Okay. I guess I can ask you the question another way. Is this dot the same distance as this dot away from the center?
Well, I had to measure it.
Right, you have to measure it, right? Now there are many dots scattered around. What would be a best way to just see it in one go? This is not really easy to see. You have to measure. But in
Can I
some way,
move them?
yes, you can move them. That's what I'm saying. You can always move them. What would you do? How would you move them?
How would I move them? I'd move all of them into the center.
No, you can't move them into the center. You have to still put them according to how far they're away from the center. How else would you do that? You can
So
change.
if it's like here,
Hmm.
it should go back a little bit.
You can't change their distance from the center.
Oh, we can.
You can just redistribute them in the axes.
Oh. So like if it's in the here and it goes here, it should actually decrease from here.
No. I mean, you can put them either on an x-axis or a y-axis, but the distance from the center should be the same.
Okay. Maybe I could put one of them aligned to the center like this.
Line to the center like
Yes,
this.
and another one aligned to the center.
Another
Then
one.
I could put only one scale there,
Mhm.
and then I could see how much distance is from the center to here and how much distance from the center is to here.
Yes, so how about the data points? Where are you putting the data points?
I'm putting the data points somewhere around here.
Which data points? All of them. In one point.
No, not putting all of them in
Shitabolo,
one
say that
point.
clearly.
Maybe, well, like we can put one of them here, 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 here,
Mhm.
and the rest of them here, 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 here.
Hmm.
And then, according to that, we can actually say
Hmm.
how much from one point to another.
Right, and then you're thinking about it in y-axis terms, right?
Yes. It could also work x-axis, which I think would be better
Hmm.
since it's actually longer than the y-axis.
Not really. This one is a oval shape, but it's if it was a circle, it would be the same x and y axis, right?
Yes.
Now look at my next slide, and you'll be surprised to see how much correct you are. Look at this. That's exactly what I did.
What? That's exactly what you did?
That's exactly what I did, and that's exactly what you said. Yeah, put the center point here. Now distribute the data points exactly according to how far they are.
Lucid, isn't this like using like average?
There you go. Why is this an average?
Because it's actually taking all of them
Right?
and then distributing them. Like
Very good.
distributing them in terms of like what average means. Like
Very
what the
good.
mathematical
Why don't you pull the chair? And this is getting into a very great discussion here. All right.
Are we recording this?
I think so, but we don't have any video. We just have the slides. We're gonna put up the slides on here. Okay.
Okay.
All right. So, average, by the way,
Yes.
it's not really distributing, but it is summing up. It's like summarizing.
Okay.
So when you say distribute something, that you mean spread out.
Mhm.
When you say we're averaging something, that means we're summing it up. But you're right, when you sum it up, that means you're putting all the data points in one place, trying to see it in one place. You're not actually putting, well, how do you do the average, for example?
Like we do the average by knowing how many points are there, adding the points up,
Hmm.
and then like dividing by that.
Yeah.
And then basically we get where each point goes, like in a line.
That's
And,
when you
like,
distribute it. Distribute it.
Hmm.
But once you said that we are summing all the data points, dividing by the number of data points,
Mhm.
out of that result, how many numbers are you getting?
How many numbers are we getting?
It's a division, right?
Yes.
So remember,
We're getting less numbers.
yes, but remember, out of that result, how many numbers are you getting? We did 40
Mhm.
divided by 10. What is this number? 4. How many numbers is here?
4. 1.
Exactly, it's just one data point, but it's just one number. What does it mean? It means,
It's actually all in one point.
very good. You can actually see
But
that.
we can actually see that by logic. But if we can't actually see that in this form,
We can.
how can we do that?
See, there is the center point.
And the center point
Is
is
it?
the point where all of them meet.
Exactly, they should be there, right? And
Yes, because that's the mean. That's the mean, the average. Where you remember you showed the bell like slope thing.
the bell curve, yes.
Yes, like it just put in the center.
It will put in the center.
And this is the mean. This is the average
It's
point.
the average point. Now there's something interesting that I want to show you that most people miss out.
What?
And it's kind of like I discovered it.
What?
I would like to say that the average
Yes.
actually represents every data point. Can you prove it to me? Mathematically. Okay, forget mathematically. Just say, does it make sense to say that the average actually
Yes.
represents everyone? You remember the word represents?
Yes.
Okay, now tell me whether the average can actually represent everyone.
Yes, it can.
How?
How? Well, the average is in the center, correct?
Okay, correct.
And look, all of these points are from here to here, right?
Right.
It's representing all of them because the average is actually one whole number
One whole number.
made out of all of these points.
There's the point. So now mathematically, when you say made out of, where do you see that in the math when you calculate average? Think how you calculate average, and the answer is there.
I add all of them up,
That's it.
make up. You add all of them up.
That means
And you add all of them up to get the average.
that means in the numerator,
Yes.
what's the numerator made out of?
The numerator is made out of adding all of these.
Everyone. The numerator is made out of every data point,
Yes.
right? Every data point. That means that the average actually contains.
Every data point.
That means it's representing everyone. Don't you think so?
Yep.
That's it. Mathematically, average represents everyone. So look at it now. Let's read the slide. How can the central value be estimated? Apply common sense, right? Look at the straight line above. Like I say about this. Data from the circle can also be organized and placed on the straight line. That's what I mean, right? How can the middle or central value be calculated? We already know the answer actually. And here's an example. Let's imagine those data dots as numbers. 10, 12, 11, 19, 15, 17. How can you calculate the middle value of all these numbers, right? Mean is the answer. Mean is a measurement calculated to obtain a central or middle value from a given set of numbers. Why do we want a middle value? Is the question. Middle represents others. It is supposed to be unbiased, looking at both sides equally. He's supposed to be unbiased. So when he looks at this guy and when he looks at this guy, he thinks, oh, they're in the same distance. Then he looks at this guy and he
So
looks
it's
at this
actually,
guy.
so for him, he's actually seeing one guy.
Kind of in a negative and positive direction.
Like a positive
Right? But he's saying unbiased. That's what he's meaning. I'm in the middle. I'm not biased. I'm not really leaning towards someone special. You know?
Yeah.
So I'm like unbiased. So mean is supposed to be an unbiased value. Okay? However, we'll later learn. However, we'll later learn that the mean is not always an unbiased value. Sometimes a biased value, and that's why we need to do something else to say how much bias is the mean. Well, you know, someone calculates the mean and says, hey, guess what? The average or the mean height of your class is 2 feet something, right? Children in class 3 is 2 feet high, 2 feet tall. Huh? And then you say, wait, this 2 feet is representing everyone. What does it tell you?
That tells us that the maximum height is actually 2 feet.
No.
What?
Look at this. This is 2 feet, the middle thing.
Yes.
The maximum is all the way there.
Yes.
Or maybe, the minimum is all the way there.
Yeah.
So this
Or
is
should
not
be the other way around.
Yes, but this is so the average is not the maximum. What is the average?
The average is the amount that you can distribute.
You can distribute, but what does an average tell you?
What does an average tell us? An average tells us middle represents others. It is supposed to be unbiased,
looking at both distances equally.
equally.
Right?
Yes.
So what is supposed to tell you? If it represents everyone,
Yes.
then what does it mean?
If it represents everyone, it means that 2 feet is representing everyone.
2 feet is representing everyone. That's right. Then if I tell you, okay, take Adil, take Nahyan or someone, I don't know, I'm just randomly saying names, okay? Take these two.
Nahyan.
I don't know. Take these 2 people,
Okay.
and then I ask you, how tall are they? What are you gonna say based on the average?
Well, I'm gonna have to see how many people are there.
No, I give you average 2
Yeah.
feet.
Okay.
Then I ask you, you're at home now, and I ask you, Hazwar, you know what? They measured the height of the students in your classroom, and they said the average is 2 feet. I'm curious, how tall is Adil? What are you gonna say? Based on the average, how tall is Adil?
2.
Yeah, it's probably 2 feet, because the 2 feet is the average, and it's representing everyone.
Yes.
Okay?
Hmm.
Then I ask you, tell me the name of another friend, Nafim, right?
Yes.
How tall is Nafim based on the average?
2 feet. It's based on the, because you said it's based on the average. If
Right,
it wasn't
because
based,
no,
if it-
because that's the only information I gave you. You don't have any more information. What can you do? Right? You didn't
Yeah.
go and measure them.
Yeah.
But in reality, you really know Nafim is a little taller or shorter than Adil.
I think he is actually. I don't know. I think they're actually sort of equal.
Okay, let's take another person. Let me
Said Abdullah. Said Abdullah is taller than Abi.
They both can't be 2 feet.
Yes.
Maybe one of them is, maybe the other one is certainly taller, or maybe the other one is certainly shorter if the other one is 2 feet, right?
Hmm.
What is it telling you about the average, by the way?
It's telling us the average. It's just taking up all of like the.
No. We know how to calculate an average. I'm saying Adil and Said Abdullah are not the same height.
Yes.
But I said, when I asked you the question, I gave you one information. The average is 2 feet. And you said, yeah, they're both 2 feet. But in reality, when you see their, imagine their pictures, you say, nope.
Yeah. That's.
Then what's the use of the average? Like, if I ask you, okay, so what do you think of using average?
Average is useful for.
Can you actually say what is it not useful for? Because now that you see already that the average is kind of messing up things.
Yes. The average actually doesn't tell you the true height. It actually tells you. Let me explain this in a different form, not mathematically form.
Okay.
And the different form is the average is actually telling us when we add up everything and divide by the numbers, it's actually showing if we make everyone the same height.
Yes.
Or everyone the same weight, or everyone the same something.
Yeah.
It's going to be a certain amount of something.
Right.
And that's the average.
And it's going to be distributed equally to everyone.
Yes.
Because that's what the division does.
And that's something that
in reality,
it's not actually that useful.
See? But
It might be useful for money purposes.
Yeah.
For money purposes.
it can be actually, it can be, okay, let's move to another room. It can be actually useful for many other things. So the only problem with that is when we say that the average is in reality is not really that much useful, but they use the average for so many different things. They have to, because they have to get an idea about everyone, right? How else could you get an idea about everyone?
Yes, but why is this thing useful?
Because, for example, you want to know what's the average income in a family, how much on an average someone earns. Okay? If you have an idea about everyone, that's fine. But let's say another thing. I want to make a playground here. I want to make a playground here. And the person who's going to give me the money asked me the question, "You really need a playground here?" I said, "Yeah, there's a big community with lots of children around." And he asks me, "Well, if it's a lot of children, that's good. But can you tell me, for every household, on an average, how many children are there?"
So it's saying if you take all the children from all the houses and distribute them equally, how many children will be in each house?
Very good. That is exactly the concept of average, right? He's trying to get an idea of how much that is, okay?
Like per house?
Per house.
Yes, so like if he does that, then he gets an idea of like if there's like 11 houses and the average is 3, he gets an idea there might be 33 children playing.
Wonderful.
It might be less or more, but he just gets an idea.
Now,
why he has to do it.
Right. Now if he wants to get an idea that, okay, the average is 3 children per household, but how much is that really true? Like some household has 1, some household maybe has 6, right?
Yeah.
So how much is that varying? If the heights are different, the number of children are different, then it will vary.
Yes,
right?
Of course.
Okay. So there is a way to calculate that variation. You
How?
That's a term called standard deviation.
Okay. Will we learn that today or tomorrow?
No, tomorrow.
Okay.
We have enough discussion about averages. And let's see what do I have other in my slides, and then we'll just move on. Then Y middle or central value. In data analysis, we deal with several values or data points for any given variable. To summarize this, we need one single value that will represent all other values. See? Also this single value, since we expect it to be representative of others, we can use this to generalize to others. So like we said, 2 feet, everyone's 2 feet. You kind of want to say that.
To get an idea.
To get an idea. Very good. So
yes, but Papua, I have a question.
Yes.
Average in some cases is actually not useful.
Yes.
Well, in most cases it's not useful. And do you know why?
Why?
In most cases it's not useful? Because to know the average, you already have to know the height or like something that you even want to know.
But let's say I tell you that we're going to measure the heights of 1 million people. Is knowing the heights of 1 million people really useful?
No, but after
I'll give you a very real example.
Okay.
There's a disease called anemia.
Ugh.
Anemia means you have less red blood cells or hemoglobin.
Okay. And more of something else.
Nah, it's just less hemoglobin. Okay?
Okay.
To get this corrected, you need iron, for example, iron capsule or something, or vitamin B or something. Okay? Now, if I want to give vitamin B or iron capsule in, let's say, Bangladesh, will I give it to everyone? Well, I don't know. Some people have anemia, some don't. We measure the hemoglobin concentration in blood by the measurement called milligram per deciliter. What does deci mean? 100. So milligram of iron,
Mm.
okay, in every 100 milliliter of blood.
Right.
If we measure that in all of the people in Bangladesh,
Mm.
they're going to be different,
Mm.
right?
Mm.
But it seems like the average is very low.
Mm.
So the average should be, let's say, 10 milligram per deciliter.
Huh.
If it's lower than that, you need iron capsule.
Mm.
Now, are you going to remember how much did everyone have hemoglobin blood pressure?
No.
What are you going to do?
I'm gonna take an average.
Exactly.
But that might ruin it. Do you know why?
Why?
Because if somehow you take all of the temperatures,
Yes.
but
Not temperature, blood samples.
yeah, blood samples.
Yes.
But if you do the average of all of those blood samples, it becomes a blood sample that doesn't need iron or like vitamin B or whatever.
When can that happen?
Good point. When can that happen?
Yes. It can either show that the average.
Yes, but sometimes if someone needs iron capsule and someone needs vitamin B,
No, let's just stick to one. Just iron.
in that case it's actually true. But in a case if it's vitamin B,
No, that's complex. Let's just think about iron capsule.
okay. If it's iron capsule, then this question actually doesn't even work.
No, it works.
No, it doesn't.
It works. Think about
Okay,
when
should
can
I
you,
tell you? Should I
when
tell
can
you?
you have an average
Hmm?
that's higher than what you already need?
Like you need an iron capsule and
Right. Let's say we need.
but you're getting a vitamin B because it's
No.
average.
Let us say you need an iron capsule when your blood hemoglobin is 10 gram per deciliter.
Hmm.
Now you measure the average in 2 million people,
Hmm.
and you get the average as 11 milligram per deciliter, which is more than what you need when you want to give an iron capsule, right?
Hmm.
When can that happen? It's a simple answer.
When?
When everyone's blood hemoglobin is high.
But
It's high. It's always going to be above 10 milligram per deciliter. When can it be low? When everyone's low. But is always the case that everyone is high and everyone is low? It's a mixture.
yes.
Now that's the reality. It's a mixture. If it's a mixture and then you get it high, remember that high average that you had
Hmm.
is a mixture of low hemoglobin people and high hemoglobin people.
Hmm.
Then still the average became on the higher side. When can that happen is the question.
Hmm.
When can that happen?
Apo-
You lost me at some point actually.
Yeah. but I got an idea while you were thinking that I was lost you at a point. I know how to do this. I know how to do this.
Okay.
Listen to me. Okay, so practically, if all of them are high,
Right?
but one of them is iron capsule,
I mean low.
yes,
Yeah.
low, then maybe because the high is on top and the low is on the bottom,
Hmm.
because of how many people are there and how
Hmm.
many of the blood
Hmm.
samples. So practically, for that reason, I could say that, yes, for that reason, I could actually say that iron capsule guy actually was something like vitamin B or whatever, you know? That could happen if a few people only needed iron capsule and the other people were high.
Why don't you say it in terms of proportion?
So, okay. So,
Let's think about all the people being 100%.
Yes.
Now you can say it.
Okay, if all the people are 100%
Mhm.
and the number of people that have high are something like 75%,
Mhm.
the other people are actually 25%.
Right.
and those need iron capsule.
They're low hemoglobin,
Yes.
right?
So practically,
What will the average be like?
the average will be like, well, all of them take blood samples.
Will the average be on the higher side or the lower side? That's the question.
It will be on the higher side.
Yeah, it's common sense. And think about the bell curve. The bell curve, the bell normal curve has the average in the middle. And on both sides, they're the same. Now, if one of the sides has more, the average would go towards the more side. Right?
Yes.
Common sense. So,
Yes, but one of them doesn't have more.
yeah, that's fine. So, now, all these things about so this is my second lecture in the class. And in this lecture, initially I had other discussions about variables and independent variables,
Were
dependent
you a
variables.
teacher?
Yeah, this is my slides, this is my lecture presentation. Look, I'll show you.
You didn't even tell me the history of this.
Look at this. See? This is my name. See? My lecture. See that?
What was this for? Students, or like you're like passing
No, this
something?
is master students in statistics.
See, I knew it. You were
Okay.
doing this for some reason instead of
And
like,
look at this, look at this. I'll show you something here interesting. Oh, it's not here, I'm sorry. This is different. Anyway, here you go, the bell curve, showing the average, the average, the average. 3 averages, see? The average is here. The average is when you distribute it. Well, you start off here. You get data points. These are all population in Bangladesh.
Papua, can you even see all of this?
Yes.
No, not like that way. Can you see all of this? If you observe this from one place or the other,
Which one? The bell
like,
curve, the
like
straight
this
line?
one and this one, if you observe this, this and this carefully, you can actually see all of them are the same.
Kirukum? How is it?
Kirkom, look. This is in this way, right?
Yeah.
So, if it was 3-dimensional, then we can take this point right here, you know, and then we can like take this, and here's the bell curve like this,
Okay.
in a straight line. It's like a straight line, like going here, from here to here, right? And if we see it like this, it actually looks completely like a straight line, which is this. And they have marked points, like this point, which is the middle, is actually this point, which is in the middle. And this is actually related to this because it's just switching out the points in different places.
I don't have any idea how you put it into 3-dimensional perspective.
No, look at this.
I know you have a you see I can't see how to see it in 3-dimensional.
No,
But
I can make you understand quicker. Please.
wait.
Papua, please.
Wait, but I gotta stop the recording because people are talking now. So here you go with the discussion. The rest of the discussion. Okay? It's recording, I don't know. Nothing's working. Time running. Oh, great. Yeah, it was recording. Okay, so we're near the end of the slide. Okay. Which is here. So this one says that you can also have data points distributed in a curve which often takes the shape of a mountain. The middle point has the maximum number of data points. Okay? Data points at the tails are less available. That means less likely to have data points here because they only go up to this height. And the height actually tells you how many data points are there. এটা কি বুঝছো? Okay. So if the height here is so much, that means many data points here. And this is the average number. So there are more of average-like things in a bell curve. Okay. This criteria of distribution of data points is related directly to central tendencies. All popular statistical calculations boils down to the criteria and this mountain-shaped curve called normal curve. That's our next day topic. Okay, so this is where we'll go next day, what the properties are. There are some things that we really missed here, which you can get later, is, you know, generalization, population, generalization, sample, representative value, central value.
Okay.
These are all related. Do you understand this?
Yeah.
Really? Can you explain the relationship here? Population, how is it related to generalization? How is it related to sample? How is it related to representative value? How is it related to central tendency or the average?
Well, population, number one, you can take average of population. Number two, sample, you can take a sample of the population.
Mm-hmm.
Now, one person can represent a lot of the population. The population, like, if someone's given birth, then the value changes. The value of the population changes.
Okay, no, the question is, how do you relate average with representative value, with generalization, with sample, population, all of this? How are all this related? Do you remember what is the population is?
Yes.
What is the population?
The population is the number of people living in the whole world.
Yes.
Or like if you want to take it from a country or something like that, you
Right.
know?
So it's everyone, basically. What is generalization?
Generalization. It generalizes some?
Yes, you generalize it to everyone. So the results apply to everyone. Generally. What is a sample?
A sample is actually taking part of the whole thing, like part of the population.
So it's like taking a proportion of the one whole thing.
Like from 100% you take 50 or 40%, like something like that.
Right, taking a sample, right? What is representative value? Or representativeness, same thing. Representative value is just a
It's
value.
actually like representative is actually like there's someone which has a special quality and many other people have that special quality. He represents everyone who has that special quality.
Very good. So a representative value is the exact value that will be representative of all the others. Right? Like you said, in the class height, 2 feet is the average. If that's the representative value, then everyone is 2 feet. Then central tendency. One of the measurement of central tendency is, you know, remember tendency is to get in the middle. So which value tends to get in the middle?
The average.
The average. So average is central tendency. Average, is average a representative value? Supposed to be? Is it supposed to be a representative value?
Yeah.
It's supposed to be a representative value, but it does not really accurately represent everyone. Why is it supposed to be a representative value?
Because it's actually taking everyone.
Right. Don't forget that. That's why everyone, if anyone asks you ever, is average a representative value? The first answer you give, yes, it is supposed to be a representative value,
Yes.
but it is not always in ideal situation a representative value.
Like
so
in real life.
if the average of a sample, meaning a part of the whole, has a representative value, then that representative value is actually representing everyone in the what? Sample that you just took. If the sample is representative of the population, then shouldn't that average that you took from the sample would also represent the population? You see the logic? You got this big population, take a sample that is representative of the population, take an average representative value from the sample. That means this average is representing everyone in the sample?
Yes.
And the sample is representing everyone in the population. So this
practically, if you take a sample, like if you take
don't take one. Take a sample. Take
like
a proportion.
100 people out of 7,000,000 people, something like that. If you take 100 people out of there, and then you get the average from something, like if you get the average of their heights, then you'll actually see, what is the average height of this many people, and this part is actually representing this. So if you find the average of this, you find the average
this and this. There are words for that.
If you take the average from the sample, then from the whole population, it's practically taking the sample from the whole population.
It's taking the average of the whole population. However, there's a problem.
What?
Those are the problems that we'll discuss later. But there's a problem. Right now, there's a clear relationship between all of these things, right? Later we will see, hey, wait a minute, you took this sample. What would happen if you take this sample out of that population?
Maybe it would be different.
Different what?
Different what? Different height.
Different average values. Different central tendency measurements, okay? Then which one will you believe? Will you believe, because now we want to talk about the entire population. And we took a sample from here and a sample from here, and they give two different averages. Which average will we generalize back to the population? Tricky situation.
The average that seems most likely.
Most likely, but how do you know which one is the most likely? You don't know the population.
Maybe if like a lot of people are tall on the population, just by looking at people, they look tall.
But you can't do that really. With 17 million people all around you, that's impossible. That's why you do mathematical calculation. And there are terms and exact calculations for it. It's so easy and it's very interesting.
Let me guess.
There's a way to say
the exact same thing we're gonna do tomorrow.
Yes, we'll discuss. We'll keep on discussing this, and this is already statistical concepts going on, and we can keep on moving with this, and statistics can just be in our grasp pretty soon.
Yes.
Okay, we will stop now, right?
Yep.